Okay, good morning everyone. Myself Dr. Rama Devi, Professor of IT Department, Ministry of Aeronautical Engineering. Yes, in today's class I will discuss equivalence formulas. Okay, here we are having the equivalence formulas. These formulas can be in, we are having starting with idempotent laws. Idempotent law. Idempotent law means P or P value is equivalent to P. Yes, P value here we are having T. T or T is equivalent to T. Its value is P. So, if the value of P we considered F or F, then its result is also F. So, it is P. We can say that. Whatever it may be, the value of P, it may be either P or Q. Then we can say that P or P is always equivalent to P. Similarly, P and P is also equivalent to P. This is called the idempotent law. Okay, the next one is associative law. Associative law means P or Q or R is equivalent to P or Q or R. Similarly, in the second one, we are having the P and Q and R. This is the R operation here we are performing. P or Q or R. Okay, here we are having condition. Yes, this is similar to P or Q or R. Like that. Similarly, for AND operation also, P and Q and R, which is also equivalent to P and Q and R. This is called the associative law. The next one is the commutative laws. Commutative laws are, here we are having the two propositions P and Q. If P or Q is equivalent to Q or P. Yes, similarly for P and Q is equivalent to Q and P. This is called the commutative law. Next one is the distributive law. Distributive law is P or Q and R. This is the Q and R. Now we are distributing this P to these values Q and R. So P or Q and P or R. P or R. So this is one formula. Similarly, P and Q or R. P and Q or R means P and Q R, P and R. Like that we can distribute. That is the distributive formula. Yes, the first one is the idempotent law. Second one is associative laws. The next one is commutative laws. The next one is the distributive laws. Yeah, the next one is identity law. Identity law means P or F is equivalent to F. P or T is equivalent to T. P and T is equivalent to P. P and F is equivalent to F. These are the identity laws. P or F is always equivalent to P. P or T is T. P and T is P. P and F is F. Next one is the component laws. Component laws are P or negation P is equivalent to T. Yes, consider P as T. Negation P as F. So, P or negation P means P value is, here we are having P value as T or F. T or F value is, what if T or F value is T, always T. So, P or negation P value is T. P and negation P. Yeah, this is the P value, this is the negation P. T and F, that is always equivalent to F. And operation between the T and F is false only. We know it. The next one is negation of negation P is always equivalent to P. Negation of T is false. Negation of false is T. The next one is the absorption loss. Absorption loss are P and Q is equivalent to P. The next one is P and P or Q is equivalent to P. Yes, this is called the absorption law. The next law is the De Morgan laws. In De Morgan laws, Here we are having negation of PRQ, which is equivalent to negation of P and Q. Here we are having this R operation is to be converted into AND operation. This negation, this is same negation of P and negation of Q. Similarly, negation of P and Q is equivalent to this AND operation that to be converted into R operation. Yes, this negation is to be distributed to both P and Q values. So we can say that these De Morgan laws, this plays very important role in our mathematics for computing problems. Yeah, we can easily identify and we can easily compute our problems by using these De Morgan laws. That is, negation of PRQ is equivalent to negation of P and negation of Q. Negation of P and Q is equivalent to negation of PR, negation of Q. The next one here we need to prove that by using the equivalence formulas. Now we need to prove that P2 Q2 R is equivalent to P2 negation of Q join R. Q and R, which is also equivalent to P and Q conditional to R using the equivalence formulas. Yes, we know P2 Q2 R, this Q2 R value is negation of QR. Yes. So, based on the equivalence formulas, the negation value is, we can say that P2Q is based on this. We can say that Q2R is negation of Q join R. And here also we are having one conditional statement. P2 negation Q2R. Again, here we need to insert one operation in between these two. P2 Q2, P2 negation QRR. Again here based on the same only. Yes, P2 negation Q join R. Just this is one operation you can feel like that. We know P2Q is always equivalent to negation of PRQ. So based on that, here also just we are placing negation of PR, QRR. Yes, this is the standard formula. Yeah, we know the associative law. Based on the associative law, now we can say that negation of PR, negation of QR, R. Yes, now I am combining these two with R. So, De Morgan laws. We know De Morgan laws. Negation of PR, negation of Q equal to negation of P and Q. This is the De Morgan law. So, based on the De Morgan law, negation of PR, negation of Q is equivalent to negation of P and Q. R, this R operation as is, this R operation, this R variable is as is. We need to place it. Yes, next one is, we know already P2Q is negation of PRQ. This is the entire one is negation of P and this is negation Q. Just imagine like that. Then we can have P and Q to R. Yeah, P2Q is always negation of PRQ. Okay, based on that, here we identified P2Q2R is equivalent to, yes, we have already this one. P2Q2 is always equivalent to P2 negation Q2R. Again, by using the De Morgan laws and associative laws in this, we obtained P and Q conditional to R. So, this is P and Q to R by using the equivalence formulas. By using truth tables also, we can construct the equivalent formulas. Okay, this is the one of the methods to identify the given formula is equivalent or not. The next one, this is also, we need to prove the yes, P2Q and Q2R to Q is equivalent to P2R to Q. Yes, ma, we know P2Q is equivalent to negation of PRQ. Similarly, R2Q is also, since P2Q is equivalent to negation PRQ. Similarly, R to Q is also equivalent to negation or join Q. Yes, these are the two. And operation as it is, we need to have the same and operation. Yeah, by using the De Morgan laws and by using the associative property and by using the distributive properties. What are the formulas we are having in our previous steps based on all those? Now we need to combine these two. Yes, in this we are having Q, in this we are having, yes, in this also we are having Q, in this also we are having Q. For both R operations we are having. So by combining negation of P and negation of Q, negation of R, this R operation just we are by using the distributive property. Yes, here we are using some distributive property. Based on the distributive property, we collected the formula. This is the equation. Okay, based on the De Morgan laws, we know negation of P and negation of R is equivalent to negation of P R R. Yes, similarly, negation of P R R. Yes, this RQ is same, no change in this. Yeah, this is P to Q is equivalent to negation P R Q. So, here we are having, this is just imagine, this is entire one is negation P R Q. So, P to Q. This is P, this is Q. So, based on the formulas, equivalence formulas, we can easily distribute by using the distributive property, by using the De Morgan laws, by using the equivalent formulas. We can say that the given formula P to Q and R to Q, which is equivalent to P R R to Q. Like that we can identify. This is also the same. P to Q to P is equivalent to negation of P to Q. This is the problem we need to solve. Yes, for this P to Q to P is negation of P R Q to P. Yes, same we will get. Yes, ma. Next Q to P value is negation of Q R P. Yes, negation of Q R P. Okay, this is, here we are having negation of P R, negation of, this is the negation of Q R P. Okay, from this, here I am using the distributive property, equivalence formulas. Okay, negation of P R P. We are combining these two, negation of P R P or negation Q. Just we are splitting the braces. Negation of Q R P. By using the formula, we can say negation of P R P or negation of Q. We know negation of P R P is always T and negation of Q we are having. So, some truth value we are having. The remaining value, it may be either true or false. Then we can say that its result as always T. We know it. T R F is T. T R T is T. Yeah. Need not to bother about the value of negation of Q. Just based on the standard equivalence formulas, we can say that T or negation of Q is T. This is for the first step, the first part. Coming to the right hand side, this is the negation of P to R. Okay, negation of P to Q. Its value P to Q. This is negation of negation P. And P to Q value is again negation of P to Q. Negation of negation P value is P. Yes, negation of negation P is P. We know it based on the equivalence formulas which we have learned. Yes, negation of negation P equal to P. Just we are keeping it as P. And we know the value of P to Q equal to negation of P to Q equal to negation of P R Q. Yes, just we have placed it. And again, we are combining P join negation P, PR negation P, R Q. Yes, its value is always true. We know it. True or Q value is Q value. It may be Q value, maybe T or F, whatever it may be. T join F equal to T. T or T equal to T. So, irrespective of the value of Q, we say that T or Q is equivalent to T. So, here we have the value as T. The result is T. In this case, its value is T. This is T. In the left hand side, value is also T. So, both P to Q to P is equivalent to negation P to Q. Yeah, by using the equivalence formulas, we notice these two. Yes, this is T, this is T. So, these two are T. We can say that this is a tautology. Since two formulas are equivalent, then we can say that the given formula is a tautology. Yes, based on that, next here we are having equivalence formula. This is also similar to that negation P and R to Q and R join P and R is equivalent to R. Here we are having some solution similar to that using the distributive laws. Distributive laws, negation P and negation Q and R. Okay, negation using the distributive laws, we can say that negation P and Q and R join Q R, P and R. Yes, associative and distributive laws, here we are having already De Morgan laws also here I am using. And negation PRQ is equivalent to negation PRQ R, PRQ and R. By using the distributive laws, we can say that our end result is R. Yes, this is the, similarly we can show that P and Q is to PRQ. This is also the tautology. By constructing truth table also, we can show that R. Without truth table also, we can easily identify P and Q to PRQ. Yes, P and Q to PRQ. P and this is the similar to the P to Q. That is negation of PRQ. This is negation of PRQ. So, by using the De Morgan laws, negation of P and Q is negation of PR, negation of Q. P and Q, similarly PRQ as is. Now again by using the associative law, this is PRP or QRR. Its value is T, its value is T, so our value is T. Like that. Here we are having the truth value as T itself. Like that we can identify. Here also I collected textbooks. J.P. Trimble Manohar Discrete Mathematics textbook and Discrete Mathematics textbook for Kenneth Rosen, that is the 6th edition. And web references also I collected from Geeks for Geeks and Mathematics for Computing, one textbook is there. So by combining all those, I have collected my references. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.